We've been talking a lot about expressions in these last couple of videos, so let's continue with that. Something like 3 more than the product of 2 and 5. Let's get another one out here. The product of 2 and 3 more than 5. That should be consistent. I'm going to write out the numbers. I'll write out the numbers. Okay, and that's not a full sentence, so I don't put a period there. So we're looking at these. 3 more than the product of these two numbers. The product of 2 and 3 more than 5. Now, I'm not yet done with this one here. This looks like 3 more than a product. I want a product of two things, right? This and here is separating the two inputs for this operation, right? You notice the product of this thing and this thing, the product of these two inputs, the product of this thing, 2, and this thing. So 3 more than 5 has to be within those grouping symbols. We traditionally use parentheses, at least in the US, to indicate that this sum, 3 more than 5, altogether is the input, one of the two inputs, for the product operation. Now, that's our translation stage. What we want to do after that is simplify or evaluate. Right? Often in algebra, we'll start with something like these written expressions. Let me just double check that. 2 times 5 plus 3. 2 times 5 plus 3, or 2 times 5 plus 3, right? The product of 2 and 3 more than 5, or 3 more than the product of 2 and 5. And when we evaluate this, we're just doing the operations. We're finding the value of this expression. 2 5s make 10. 3 more than 10 is 13. The value of 2 times 5 plus 3 is 13. We've evaluated this expression. Here, 3 more than 5 is 8, and 2 8s is 16. So the value of 2 times 5 plus 3 is 16. Right? That's what it means to evaluate. But we often use this word evaluate in slightly different contexts. Right? If I switch colors here, another example here, 2 times x plus 3. Well, 2 times x, I know what 2 times 5 is, that's 10. I know what 2 times 8 is, that's 16. 2 x's, I can't know that until someone tells me the value of x. And if I'm at wherever x is on the number line, we'll assume that it's positive, though that's not always true. I can double that to get to 2x, add 3 to it to get to 2x plus 3 more, but I have no idea where this is on the number line unless someone tells me the value of x. I can't evaluate this. I don't have enough information. Well, that's why in algebra, we often use this word evaluate. Find the value of the expression for the given values of the variables. In algebra, we have a slightly different use of this word evaluate, because we'll say evaluate 2x plus 3 for this particular number. So instead of 2x plus 3, I'm going to replace x with that number. I know what 2 sevens is. That's 14. And 3 more than 14 is 17. I can find the value. If this is 7, 2 sevens makes 14, and 14 plus 3 more is 17. I can only find the value if someone tells me, I can only find the value of the whole expression if someone tells me the value of x. So we often get these two words mixed up here. Evaluate and simplify. When we're only dealing with numbers, these words are synonyms. Right? But once we get variables in there, it gets a little more complicated. So if I have 3 times x plus 2, perform all operations, x plus 2 I can't perform. I don't know what's 2 more than x. But I know what 3 times something means. 3 times something means that thing 3 times. So I have x plus 2, and another x plus 2, and another x plus 2. So I have x plus x plus x, 3 x's. And I have 2 plus 2 plus 2. I'm adding those 2's to my x's. 2 plus 2 plus 2 is 6. So I can rewrite this expression without parentheses, and that's considered more simplified. So let's pretty up our definition here. Perform all possible operations. I can't multiply without knowing the value of x here, so that's an operation I can't carry out right now. But I still have multiplication and addition. I started with multiplication and addition. It doesn't seem like it's much better. So we need actually a slightly more nuanced definition here. Simplify means perform all possible operations and follow mathematical rules, mathematical conventions. Should I use the same definition every time? Mathematical conventions of syntax. Syntax is just like the rules, the grammar of the language. So in English, we'll say the syntax is you put a period at the end of a sentence. When you start a word with when you start a sentence with a noun, that noun is the subject. When you start a sentence with a verb, that makes it a command sentence, right? I'm telling you to do something, or I'm describing an action. We have all kinds of rules. I'm not trying to teach you English grammar, but mathematical grammar is what simplifying is all about here. So if I have 3x, that's considered nicer looking than saying x3. Technically, it means the same thing. This doesn't mean x to the third power. I have a number and a variable next to each other, but that's just not the way we do things. We have agreed over history that we've all chosen. We put the number in front of the variable. That's what makes it simplified. I could have said 6 plus 3x, and that's actually just as good. Both of these would be marked full credit. Right, so as we move along this semester and in the coming terms, we'll look occasionally at what those syntax rules are and make sure we remember them every time. But for now, we just have to remember that that's something to pay attention to. So let's do a few more examples of these. Let's evaluate a few more problems here. Let's say, we got these two expressions. And I put a mustache on my Z so it doesn't look like a 2. It's kind of a European convention. Now, right now, we can't do anything here. Hopefully, we recognize that this means I'm adding. This means I'm subtracting. This means I'm multiplying because I have two variables next to each other. This Z being little and up high means I'm using an exponent. But I can't do anything unless and until that's a fat one there. Unless and until I give you actual values for these variables. And now that I have numbers here, instead of x, I can write in its number. Instead of y, I can write in its number. And instead of z, I can write in its number. Same thing over here. Instead of x next to z, I can put in their numbers here, plus this thing raised to this power. Now, not everyone does this step where we put our parentheses there, but I think it's really important. As soon as we deal with negative numbers, as soon as we deal with more complicated substitution where we say, instead of z equals 2, we'll say z equals 2 plus x or something like that, we need to clearly see where the operations are, what the inputs are for each operation. And giving myself empty parentheses is a helpful way to do that. So x was 5, so I put in a 5 here. Y I'm saying is 7, so I put a 7 here. Z I'm saying is 2, put a 2 there. So my expression is 5 plus 7 minus 2. Here x is 5, z is 2, so that's 5 times 2, not 52. Right? It's important to recognize that multiplication there. Plus y is 7, z is 2, so plus 7 squared. So plus, that's separating this term from that term, so 5 times 2 is 10, plus 7 to the second power, that means 7 times itself 2 times, 7 times 7, 49. Now I can add 10 plus 49 is 59. That's a single value. I can plot that point on the number line. That's the value of this expression for these given values of each of the variables. Same thing over here, 5 plus 7 is 12. 12 minus 2 is 10. Here's my value of this expression. So once I've done my substitution, now I'm doing an arithmetic problem. I'm just simplifying, performing the operations that are there, using the numbers that are given.